Okay, so now in the next part of this lesson, we're gonna look into how the graphs of the inverse function and the function, or the graph of f and f inverse, are related to one another. So in other words, we want to look at how the rates of change of the graphs are related to each other, or how the slopes of the graphs are related to one another, or in other words, how the derivatives of the graphs are related to one another. So for this example, we're going to have f of x be equal to x squared, and then its inverse, f inverse of x, will be equal to the square root of x. So let's first draw a little sketch of each of those. So f of x will go through 1, 1, 2, not 2, 3, but 2, 4, and 3, 9. What's another good? I'll do for now. Nope. I'll not do. There we go. There's f. F inverse, or the square root of x function, will be going through 1, 1, 4, 2, 9, 3, and then 16, 4. So there you go, f inverse. Okay, so now for this example, we're going to be looking at the derivative of f at 2 and the derivative of f inverse at 4. So let's find what the derivative function is first for f of x. So f prime of x will be equal to 2x. So then f prime of 2 will be equal to 2 times 2, or 4. Now, let's look at the derivative of the f inverse function. So let's remember that the square root of x is the same as x to the 1/2 power. So then the derivative of f inverse will be the equal to 1/2 times x to the negative 1/2, or 1 over 2 times the square root of x. So then so the derivative of f inverse at 4 will then just be 1 over 2 times the square root of 4. So 1 over 2 times the square root of 4, which is 2. So 1 over 2 times 2, so 1/4. Okay, so we got a 4 and a 1/4. A 4 and a 1/4. So we got a 4 in both of those. But let's see, if that's a coincidence or no. It's just a 4. What's the big deal? So let's see, what would f prime of 3 be? So f prime of 3, you got to plug 3 into this equation. F prime of 3 will be 2 times 3, which will be 6. Okay. Now, what would f prime of the inverse be at 9? So let's plug in 9 into this equation. So we would get that the derivative of f inverse at 9 will be 1 over 2 times the square root of 9. 1 over 2 times the square root of 9. The square root of 9 is 3, so this is 1 over 2 times 3, or just 1/6, or 1 over 6. So I got a 6 in both of these, and I got a 4 in both of these, but more specifically, I got 2 answers that were the reciprocals of one another. So in both cases, the slopes are reciprocals of one another. So let's write this. What do we notice? In both cases, the slopes are reciprocals of one another. of one another. Now, why do I say slopes? And then what am I getting at? Well, remember that the derivative of a function is the slope of the tangent line of that function at specific points. So the derivative of f at 2 is the slope of the tangent line when x is 2. In other words, the slope of the tangent line at this point is 4. So let's draw a sketch of that. So on the graph of f, when x is 2, so this point right here, the slope of this tangent line is 4. And the slope of the tangent line of the inverse function when x is 4 is 1/4. So at this point here, this tangent line would have a slope of 1/4. Okay, so these are slopes, but let's look at this other one now just to see exactly how the points relate. Because the slope of the tangent line of f when x is 3 is 6. So the slope of the tangent line at this point here is 6. And the slope of the tangent line of this point here is 1/6, because f prime of f inverse is 1/6. So this tangent line right here has a slope of 1/6. So you can see the reciprocals of the slopes, and now let's look at the points specifically. This point is 4/2, and this point is 2/4. This point here is 9/3, and this point here is 3/9. And yes, you can keep on showing this for all the points on each graph. You can show for the points 16/4, 25/5, any number. It doesn't have to be those numbers or the whole, the perfect squares. I just picked those are easy to work with. But every point will have this relationship when you have the graph of the function and its inverse function. So let's go ahead, let's summarize that. So the slope of the tangent line of f, tangent line of f at, let's pick a point, let's name it xy. So at any point xy, this slope will be, the reciprocal of this slope is I gotta use proper grammar here, don't I? Is the reciprocal, is reciprocal of the slope of the tangent line of f inverse at, not at xy, but at yx, because see the points or the coordinates x and y are swapped. And there you go. So that's why the graphs of inverse functions have reciprocal slopes of each other. So there you go, and I hope that helps. So good luck.